Okay, so let me go back to all the way to the beginning. So you can see that I changed the title slightly. At first, I mentioned LCD. Uh, so actually, LCD is a special case of the umbrella term, the global term, cluster analysis. Okay, so the topic is about text mining. What is text mining? Well, you know what? Okay, okay. I don't see the, I don't see the green frame. Okay, can you see my screen?
Yes, I can see your screen.
Oh, okay, yeah, okay. You know what? Okay, usually I share my screen using Zoom. I see the green frame, but now I don't see it. Huh.
No,
Okay,
it's okay.
yeah. Okay. Okay. So I will continue. Okay. In case you cannot see what I talk about, then just yell, "Hey, you!" Okay. What's text mining? Well, text mining, also known as text analytics. You may say it's a process of extracting useful information from documents, from non-numeric data, open-ended data. The process, the means, is data exploration, look around, search around. The end, the ultimate goal is pattern recognition. So what is the big picture, the overall landscape, and so on? Text mining is the best way to, to handle unstructured data. Well, today, we have Facebook, social media, we have feedback from a customer, post on Amazon, eBay, and so on. So, actually, the amount, the volume of unstructured data far outnumber conventional structured data. However, it's not the main reason that we use text mining. Well, what is the main reason? Okay, hold on. Okay, so first of all, text mining is not something totally new. Indeed, before using a computer, before AI, before natural language processing, and so on, and people have been using content analysis, grounded theory. Well, I have only an hour today, so I cannot go into a detail. But you are welcome to read my paper. This paper was published in 2011. So 2011, but I think they they repost it or restructure it in 2014. So this paper talk about the connection, the relationship between traditional classical ground theory, content analysis, and also the modern text mining. So, okay, simply put, and content content and content analysis to read the content, okay, to extract key terms, ideas, and then count how often, the frequency, how often do people mention this, how often do people mention that, and so on. Ground theory is one step further, rather than look at, the terms, the usage by the users, the respondents. Then you go one step further to to uh, to extract concepts, construct, and then you ground your theory on the data. Okay, so uh, and as mentioned before, when no AI, no computer, uh, then you rely on hand coding, right? So it's a very tedious process. Okay, and some people use a software. Um, However, the process is not automatic. It's not automated. Somebody should read. I mean, human coders, a human. So you know, you can hire a student to do that. Okay, spend like 10 hours or longer to read through like 3,000 passage. Okay, and then and then use a software like this one, MAXQDA. So maximize qualitative data analysis and read the passage and then classify the passage by drag and drop. So on the left hand side are ideas, concept. Then you read it. Okay, yeah, I think he mean this. Then drag it, drag it, drag it. Okay, so you classify the content by dragging and dropping. You may say, this is semi-automatic. Oh, it's still better than doing in Excel or MS Word. The problem is, humans are humans, right? Okay, so and humans are subjective, may be biased, also fatigued, also take forever when you have big data, right? Okay, so and when people they classify the text and then they found out the interrelationship. What you see, is a visual presentation of an Excel spreadsheet. So in Excel, you may put this concept, this idea as a matrix, row by column matrix, and then you put down the number. So how often when people they mention accomplish, how often do they also mention talent and so on, right? So this is a symmetrical matrix, and the count of co-occurrence, or you may say, the association between concepts is depicted by the size, also the color of the square. Like this one, you see a big red square, which means, when people they mention this concept, they tend to mention that concept. Okay, so why is important? What is the big deal? Well, now we look at another precursor or forerunner of text mining is Professor Don Swanson. And so he invented a process called the Swanson process. The idea is concept linking. It's exactly what I told you before, right? Okay, so you have this concept. Okay, what is the association? Okay, so and he used this idea manually. The key is manually. Okay, scrutinize the literature and found the relationship between some event that appeared to be unrelated. Okay, like consumption of fish oil. Okay, and also the Raynaud syndrome. Okay, so then he looked at this. Well, when researchers mention A, they also mention B. When researchers mention B, they also mention C. He see the co-frequency, the co-occurrence. They appear hand in hand, side by side. There may be some relationship. Then you know what? He creates some conjecture. Later, other people follow the conjecture and then found data to substantiate the association. And also he used another, okay, not another, but the same method, concept linking. And then he found the link. He looked at the literature and found the link between stress, migraine, and also magnesium. And at first, it's nothing more than a conjecture, but later, people collect data to support, to substantiate the claim. Okay, so what is that? Well, you may say, it's text mining by hand. The key is manually, well, okay, but something even more interesting. Professor Don Swanson, who is he? So you may say, well, then he must be a surgeon, a physician, and so on. No, actually, he had no formal training in biomedical. So he received a BS in physics at Caltech, the Pasadena. Okay. Also a PhD, also in physics from UC Berkeley. And then after graduation, he worked in several labs. Okay, but nothing about biology. Okay, nothing about about med school, and later he become a professor, also the dean of library science. Okay, so how could someone not in the field make such important contribution? Well, the key is concept linking. So today we call this process Swanson process, and we are able to actualize, to implement the Swanson process using text mining. Okay, so the key is that text mining is not something new. People have been doing that by hand, but now we have technology to to make the process automatic. Well, so what is the technology to make text mining automatic? And so text mining enhance grounded theory, content analysis, concept linking, Swanson process by automation, and well, AI, right? So now we have AI, and text mining is based upon a natural language processing, a subfield of AI, and also computational linguistics. So, and why do we need natural language processing? Well, okay, the software app must be smart enough to understand the context. My title is okay, what is the best? Well, so now you may say, well, now we have automate process. Of course, this is a much better, much more efficient than to read the text by hand, right? By humans. Okay. The problem is, there are quite a few challenges to natural language processing. In some tricky situation, the AI system can be full. Well, for example, incorrect stop word removal. Also, what if somebody, say, oh, yeah, I like it, wonderful, but, he mean the opposite, sarcastic expression, negation, okay, variant shifting. The last one is a realist, which means, counterfactual. And what if something else happened? Okay, so we'll go over this one by one. Well, it's quite common that when you hand over your text to a machine, to an AI system, then the first step is to clean the data, right? Okay, there are some common words, a, and, the, is, are, however, although, but, okay, well, this is not important. Take that away. Well, this process necessity well-written AI algorithm. If not, then in some situation, important information might be lost. For example, to be or not to be, that is the question. Well, to, well, not important. Be, not important. Or not important. The whole sentence is erased. Well, then you miss you miss the most important phrase by Shakespeare. If this is to be, is up to me. If not important, it not important, is not important. So when you take away the whole thing, then you miss something very important. The next one. Okay, Brazil traveler to USA need a visa. Okay, well, to is unimportant. Take away. Well, so when you completely hand over your judgment to AI, well, then it's better you count on yourself, no AI, right? Yeah. So, in Chinese, we have a saying, when you completely trust the book, it's better not, have no book. Okay. So the solution is a BERT. Okay, what's BERT? BERT stands for bidirectional encoder representation from transformer. BERT was invented by Google researcher of AI language in 2018 and 19. So I believe the paper was released in 2018 and then fully implemented in 2019. And you can, you can find the paper on the web. And the paper is short, that's all. It takes like a few minutes to read it. Okay, so okay, what's that? Well, the traditional AI system read the sentence sequentially, right, from left to right in English. For Chinese or Hebrew, from right to left. Okay, then the problem is, well, so and oh, it's unimportant. Then or two is MR and okay, remove it. In BERT, the reading is bidirectional, which means we read the whole sentence at once to determine the role of surrounding words, left and right, including common words. And so another key point is a transformer, right? So the encoder, from a transformer. Transformer was created by Google 1 year before, 2017. It's a mechanism that learns the contextual relation between words. Once again, you can find the paper on the web. And once again, this is very short. This is it takes just a few minutes to read it. I like it, So, concise. Okay, I like concise paper. Get to the point. Get to the bottom line. Okay, don't ask me to read 40 pages to learn what you mean. Okay, good. So, okay, BERT. Okay, now let's go back to the sentence. In the sentence, 2019, Brazil traveler to USA need a visa. Okay, how the word to and other words relate is important, right? You need to know which direction to and from, right? And older NLP, older natural language processing, misinterpret the first sentence. Okay, as the visa requirement of U.S. citizen traveling to Brazil. Okay, so U.S. citizens do not need a visa if they are traveling to Brazil and so. Okay, well, actually, it's not what the sentence means. So with BERT, Google NLP is able to learn that actually the word to matters a lot in this context. So now you can see that Google returns some correct entries. Okay, so waiver program. Your passport comply with all visa waiver program requirement. If you meet the requirement, then you don't need to apply for a visa to the US. Okay. Okay, so the next challenge is what if the sentence does not mean that? Do not read it in a literal sense. So it means to be sarcastic. So when the writer makes a sarcastic expression, it could fool a regular text mining software package. Consider this feedback from a student. Professor Yu is a great professor. I love Professor Yu. Easy exam, easy assignment. I never study. I close my eye. I still got an A. I love Dr. Yu. Well, do you think the student, is making a compliment? Yeah, I made screen capture from ratemyprofessor.com. Not me, it's well, second easier class I have ever taken in my life. Well, so what does it mean? Okay, is a compliment or not? Okay, or consider this one, and then I see the disinfectant where it lock it out in a minute, 1 minute, and is there a way we can do something like that by injection inside or almost a cleaning? Because you see get it in the lung and it does a tremendous number on the lung. So it would be interesting to check that. So, you're going to have to use medical doctor with, it sounds interesting to me. Well, so how can you, not you, but how can the AI system, the text mining system, correctly interpret this passage. So is a sarcastic or is a serious? Okay, and the answer is a CNN. CNN is the traditional neural network, convolutional neural network, and simply model local features to learn the global features. Okay, and to detect whether the passage is serious or sarcastic by detecting contradiction. For example, I love the pain of breakup. Well, pain is not good. You are not supposed to love pain. Breakup is not good. You are not supposed, to love breakup. Then, so it may mean the opposite, right? I work so hard to be so poor. Work so hard is a good thing, but poor is not a good thing. Well, okay. Truly, you have a dissonant intellect. Well, they are contradictory. So you must mean something opposite. Okay. Negation. Well, so the positive polarity is reversed by just one single negative word. For example, no one thing is good. In this case, although good is something good, something positive, but when you say no one, when you add no, then the whole thing change, right? Or parking on a hill with no curve. Okay, so when you remove the no, then or on or a, then parking a hill, then curve. Well, the system will totally misinterpret this solution. Once again, you get BERT. Okay, so and the older Google NLP ignore no, but now so when you take the whole thing into account, then then the Google know that you mean if there's no curve, then do this, turn the wheel towards the side, blah blah blah. Okay, parking on the hill. Okay, value shifting. In some cases, a single word in a sentence shifts the meaning. For example, this is a missed opportunity. The medicine kill cancer cell. Okay, so you need to to have the AI system take the whole sentence into account. Okay, and also how about counterfactual? Okay, so the sentence is conditional, and which means well, and okay, it could be either way. For example, oh, it would be better if the Wi-Fi network is faster. What does it mean? The student may say, well, it's okay. I'm happy with the current Wi-Fi network, but you know what? I expect something more. I want to watch YouTube videos, so I expect more bandwidth. But it may be the case that so he could not stand it. Too slow. Okay, it would be better. So what does it mean when you see something counterfactual? Are you happy with the current situation or not? Okay. Okay. So, okay, what is the take-home message? With all this, potential shortcoming, potential misunderstanding, when you completely hand over, your judgment to AI, to automated text mining, your results may be off, right? Remember, BERT, was introduced in 2019, which means before that, many passage, could have been misinterpreted, right? So that's why you need, to have a mixture. And on one hand, you let automate text mining, to take the first round, but then later you have to check the data using your best judgment. Okay, now let's look at some example. Okay, so I have a open-ended survey collected from a U.S. Southwestern University. So one question is open. Is like this: if you had the choice, the ability to design your ideal online learning environment, what would you do? What would you like to see? How would it look and feel? What features would it have? So the sample size is about like 3,000 plus. Well, you know, compared with the corporation, Amazon, eBay, this is nothing, right? They have like millions, million feedback from customer. Okay, but you know, still 3,000 plus when you use the traditional content analysis, ground theory, it takes forever. Okay, so now you know what? So I use SAS to do it. Okay, so now let's look at this result, the stop words. Well, you know, I need to do more because like one also, you know, just and so the stop word removal isn't good. I need to, you know, do some manually cleaning by hand. But you know, I look at the concept, the phrase. Well, it's good, right? Online learning, okay, easy to use, user friendliness, and so on. So I do. So I can extract some ideas, some concept from the student. Okay, but you know I cannot just stop here. So now I turn it over to latent cluster analysis. LC is a form of cluster analysis for textual data. So you know it cannot be used for numeric data. Okay. The goal is to group similar concepts or terms together, right? So now, you know, here you see like there, wow, online learning environment. Okay, so, and too many. I want to like, you know, to find out some common global themes, okay, topics, okay. Then I can use LCA, okay, latent class. Okay, what's latent? Which means, you know, is not visible as opposed to something you observe. Okay, so when you condense what you observe into some latent constructs, then it's called latent class. Okay, so now you know I have this the top terms, and then the system suggests actually I can choose how many cluster, how many how many group. And now I try 5. Okay, so you can choose like 3 or 4 or 6. Okay, but the point is that you know something I can manage, not like 10 or 15. Okay, now I have 5 cluster extract from cluster analysis from LCA. Then I want to project this cluster into MDS, multi-dimensional scaling. What's that? Well, you know, you may say, each concept is potentially one item, standalone, right? Okay, then you know, I want to compress multi-dimensional, okay, onto a 2D surface. Okay, so now I have like you know MDS 1 and 2. Then I compress them. Then I can see these 5 concepts or 5 cluster. They are far apart from each other, right? Yeah. So they are quite distinct. So and which means when people say something in this cluster, then suppose that those terms are not similar to people, you know, to the terms, to the wording in other cluster. But you know, I cannot just say, oh yeah, this is AI, yeah, so I trust AI. Okay, now it's done. No, rather, you know, it's better that I use my human judgment. I use my intellect. Yeah. So then I say, then I select the first cluster. Show me what they are. Show text, right? Then I read it. Yeah. Now me, not the machine, not you know, now human learning, not machine learning. Now I read it. Okay, user-friendly, better GUI, more visual stimulating, more intuitive GUI, user-friendly, user-friendly. Well, okay, wow, I got it. So now, in this cluster, well, the, the, the overarching theme is, you may say, user interface, user friendliness. Okay, uh, okay. Now I try another one, cluster 2. Okay, what is that? Okay, now it's a human intelligence, not artificial intelligence. Now I read it. Okay, recording of lectures, a forum on the class site to talk about lecture and assignment, a list of assignment, a list of homework item, download and update, and a forum. Okay, so the video lecture, quality video feed, recording of the lecture, a schedule of class assignment. Oh, okay. Also, lecture PowerPoint post. Look like some forum, or you may say some some hub for me to access the learning materials. Oh, okay, great. Okay, so then I can name the cluster or the concept. Concept 1, user friendliness or user interface, accessibility to cost-related resources. And then I read 3 or 4 or 5 and so on. See, I did not completely hand over my judgment to automated text mining. So I use a human intelligence to supplement artificial intelligence. Okay, now let's look at, this is the sentiment analysis. Okay, so here, I can say, well, uh, they are they are one they are 1,090 cases. They display positive sentiment. They feel good, and 121 cases displays something negative, and also the score. Okay, so and well, like problem -60, right? Negative, but like easy, ideal, good, and so on. So here it shows you like the overall big picture. Okay, so here is IBM modeler, the same data. Okay, here you see the recurring terms and phrase. Okay, and 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 now I do one step further, and the recurring terms and phrase are written by the users. So if I do that only, then it's nothing more than traditional content analysis. I count how many people mention this, how often people mention that. Okay, but now when I want to to build a concept, then I go one step further to ground the theory. Okay, what does the term mean? What is the concept? So the same idea, like here, rather than I just look at like this raw phrase and terms. Now I condense them to 5 concepts. So from content analysis to grounded theory. Okay, but more. Now I'm so now I can also replicate the Swanson process. Yeah, the professor of library science. Okay, what does it mean? Well, okay, now I have this. Now I build this concept, and then I know how often how often they show up. At this point, it's just like content analysis. But when I go one step further, then it becomes the Swanson process, concept linking. How these concepts are related to each other? Well, okay, so and okay, so I can adjust the bar. Okay, I can see more, I can see less, and so on. The point is that just like Professor Don Swanson, I want to find out when people mention A, what else do they mention? Oh, people mention A. They also mention B. When people mention B, they also mention C. And hopefully I can discover something that people ignore before, right? Yeah, okay. I will be the next Professor Swanson. I will be famous, I hope. Okay. So, and this is similar to, to correlation chart that I show you in MAXQDA, right? So, in MAXQDA, in the correlation matrix, you see something like the Excel row by column and so on. So, in MAXQDA, they use the color and also the size to show you the interrelationship. But this one use how thick the line is. So academic, also empowerment. Okay, now you see a thick line. Then it means when people they talk about the concept of academic, they also talk about empowerment. Okay, bingo. Then we need to think about how to build an ideal learning environment to empower the student. Okay, so also as I showed before, right? So okay, before that, you can see a short term, and then you see the text, the same idea, and I should drill down. I should drill down from I should drill down from concept to the actual text, and so I can read the actual passage to find out whether it's what they mean. Okay. Okay, now I want to talk about like another technique to replicate concept linking or the Swanson process. Okay, look familiar, right? Yeah, Excel spreadsheet. Yeah, so nothing fancy. Row by column matrix. Okay, so okay, S1, S2, these are like a statement, or you may say like a phrase and terms. Okay, so now I want to extract, concept. And one way to do that is that, okay, so I use a hierarchical clustering. Okay, so here, for example, let's say, and when people, they mention S4, statement 4, how often they also mention statement 2 and so on, right? Okay, and the paper, well, oh, you know what? I think it should be 2019 typo. Okay, the paper is quite recent. We present this early this year, before the pandemic. Okay, okay, so in hierarchical clustering, well, and in hierarchical, okay, we use a robust method. So when you try to look at the proximity, the response pattern. So how far away these statements are from each other. So in terms of like frequency, co-occurrence, then an outlier may skew the grouping patterns. So when a column has outlier, then the estimate of the SD is inflated. That's why I use a robust method. So by doing that, I did not erase outliers. Rather, I make them stand out. So, when they're outlier, then they become isolated cluster. And then all the remaining, can be formed more accurate cluster. Okay, so, and then you can look at, how many groups. Okay, and I look at this one. I think, okay, there should be 5. Okay. And also, once again, I can project the same data using MDS, multi-dimensional scaling. Now I compare them side by side, and they look like, well, okay, look like they are, in most cases, they agree each other. But like, well, there are some long range. Okay, that they don't belong here. Well, there are some discrepancy. When this happened, then I invoked a Biplot. Okay, this is another way, to look at the data in terms of, okay, principal components. Okay, so to check the hierarchical, also MDS, I use the Biplot in k-mean clustering. Okay, what's Biplot? Bi means two, right? Bicycle, two wheels, right? So it means what you're looking at is both the subject space and the variable space. Okay, or you may say, it's like, it's a visual translation of the matrix algebras into vector geometry. Okay, so and I want to show you the graph. Okay, for illustration. Okay, and here here is the MDS. Okay, and okay, so this one is the Biplot. Okay, we make it smaller. Okay, and okay, and then the last one or the first one is oh, okay, well, okay, what happened? Okay, and last one, okay, is this one. Okay, just a moment. I have two screens, so now I try to drag the. Okay, so this is the okay, hierarchical, and so when the good thing is that this graphic, they are interactive, they are dynamic. So let's say I look at the initial output, I don't like it. Well, so I can let me see. I can. So if I now the screen is too small. Okay. So if I drag it, okay, can you see the color change, right? Yeah. So if I drag it, I can see, okay, now this is a 5 group, this is 4 group, this is a 3, this is a 6, 7, 11. Well, you know what? Then all of them, okay, yeah. Then I can, go back and forth, use my human judgment rather than I hand over. You know what? Now you see like a 5 cluster. Actually, at first it was a 7, but I read the data, and then I use my human intelligence to override the AI. So now I say, okay, 5 is good. So okay, so then and so I also I go here. I can I can select this. Then I can just reassign the color. Okay, yeah. So I can select the to the item, the term, and then I can say, well, okay, they don't belong there. Then I can reassign, okay, based on the grouping pattern. But one more thing I can do is that, as mentioned before, how about look at the Biplots? So now I look at this cluster. I can rotate them, and see whether everyone can fit into a particular concept topic. So this is interactive. Okay, I can do that. Okay, now let me strung off them. Okay, so okay, now summary, conclusion, and well, content analysis, ground theory, Swanson process are precursor of text mining. Okay, all are done by hand, by human. Now we have AI, we have NLP, so we can automate this process. However, when you completely hand over your judgment to AI, then be careful, because there are some situations, for example, like incorrect stop words, sarcastic expression, negation may fool even the best NLP. Remember, BERT was introduced in 2018 to 19. What happened before that? Okay, so the automate process must be checked by humans. And correlation matrix, in MAXQDA, also a concept web in IBM modeler, also okay, latent class analysis, hierarchical clustering, multi-dimensional scaling, Biplot, and so on in SAS could be employed. I use all of them. I do not run a single analysis and then jump to conclusion. I want triangulation. So which means try means like a free, but you can use 3 or 4 or 5. Okay, so Don't put all eggs into one basket. Okay, some authors suggest ensemble method, such as using multiple text mining tools, and then assign reliability index to each of the results. Okay, next, then the research, typo, researcher, not the research, sorry. The researcher can select the best text mining output or combine all results to create a meta result. This idea, the ensemble method, actually is also quite recent. And okay, before that, people may use, like in when they handle numbers, when they handle data which are numeric, they may use a decision tree, also the random forest, or we maybe support vector machine, okay, gradient, boost tree, and so on. But now, in several programs, you can run all of them. Decision tree, support the vector machine, the random forest, and so on. And then put them together, so ensemble means a collection of models, a collection of different models. And then you can do model comparison to pick the best, or to do model averaging. The same idea. So how about you use a different text miner, and then you do a model comparison. Okay, so triangulation between the result cooked by human and concept extract by text mining is good for a small project. So sometimes I use both MAXQDA, content analysis, ground theory, made by human. Well, actually not me. I hire a student to do that. I ask my research assistant. Okay, and also I use IBM modeler, SAS, and so on. Then then I check, to see whether they point to the same conclusion. But it works only for a small project, so when there are too many documents, then it's better that, still it's good for you to do that. To do both, but sample only a subset for human coders. Don't ask your assistant to read 5,000 essays. Okay, so so the conclusion is what is the best? Well, not a single one. Not a single one is the best. The best is triangulation, ensemble method. Do all of them. Don't put all eggs into one basket. Okay, so I end my talk here, and I have a few minutes in case somebody want to ask me a question.
Okay, great. If you have any question, you can put your question at the Q&A chat, and we'll invite Dr. Chu to share your thoughts.
Okay, let me get to my.
Can you see the question here, Dr. Chu? The first one is, what is the name of the tool that you are using?
Okay, what's the name of the tool? Okay, I use Servo, and for the traditional content analysis and ground theory, I use MAXQDA. This software is made by a company in Germany. So and you can just search in Google MAXQDA, and the price is, okay, no big deal. Like I think $400-500. And then for the MDS, for the hierarchical clustering, and also LCD text explorer. This is Jump. Jump is a module made by the SAS. Okay, so SAS is the world's largest software vendor in data in the data analysis, and JUMP is a special module, and SAS and JUMP are interchangeable, intercompatible. And then for the concept web, okay, and that one is I use IBM SPSS model. Now, okay, SPSS is is owned by okay IBM. Okay. Okay, I can see the next. Okay, so okay, can I answer your question?
Sure.
Okay, great. Okay, any open source package for content linking? Well, okay, you can. So I think okay, you can use Python to do that, but it takes a lot of programming effort. So and in my humble opinions, I think it's not too expensive, like JUMP. Okay, SAS JUMP, and for academics, the license is only a few $1,000, and but then the whole campus can use it. Time is money. When you use open source, yeah, it's free, but then you have to to learn it and then to okay program it. I'm sure Python can do that. I am not sure about our language, or perhaps some of you guys are our programmer. Then you can answer the questions. Okay. Okay. The next question is how do you write up the results of your analysis? Okay. Well. So I can show you my okay. I can show you my example. Okay. So and okay, here is my
do you want to share screen?
Oh yeah. Okay.
Okay.
Yeah. Okay. Hold on. Okay. So okay. Let me share the screen. Okay. Yeah. Okay. Share screen. Okay. So and okay, here okay, you can see I use both content analysis and text mining, and the paper was published well a few years ago. Okay, and okay, like okay, what you saw in my presentation, right? Okay, so here I show like the human made concept, okay, by content analysis, and then here is the methodology. I talk about the software tools I use, like MAXQDA, and then IBM okay modeler, and okay, the result section is here. So it's just like, well, frequency. So one dimension, okay, the frequency, and then here is let's see, the correlation matrix. Okay, here is the the Excel show the number, and then on the right hand side is the correlation matrix, and then here the concept web, Swanson process, concept linking, right? Yeah. Okay. So and yeah, so this is and okay, I have several papers. I don't have time to show you all of them, but like in some paper I use I also show the MDS, the hierarchical clustering, and so on. And the main point is that it's better to show the graphic, showing, not telling. I mean, when you write about that, so it takes too long. People cannot understand. But when you show the graph, the concept web, the MDS graph, the LCD graph, and so on, then then your audience will I see, yeah. Okay. Okay, now well, it's almost 6 o'clock. Okay. Okay, I can answer like just okay, only a few more. Okay. how you how good can BERT manage sarcastic and other similar expression? Well, I don't work at Google, so I cannot speak for them. But I can tell you based on what I understand. I could be wrong. Okay, so and well, the power of BERT is that so it read the whole thing at once. Okay, and so to look, so the meaning of each word is based upon like what is on the left, what is on the right, and okay, so then which means this is contextual, yeah. So the okay, some text mining program is contextless. Okay, but BERT is a contextual, which means so this is better than contextless text mining software to detect sarcastic expression, but still not 100% foolproof. Well, you know what? To try it, you can just open Google and then you type something silly and then see what it returns to you. Okay, so is there a program that handles the similar content analysis boundary for conversational text? Observe the relationship between each conversational exchange or ground of exchange. Okay, look like you're asking for some natural language processing. Well, yeah, so you want to understand conversational exchange. Okay, so and okay, so far okay, so far I've been using like Jump Text Explorer, IBM modeler, and well, okay, for doing what you want to do, I think you need to go one step higher. Is the SAS text miler that is in a SAS enterprise miler. Okay, also SAS wire. Okay, I want to tell you that I don't work for SAS. I'm not, receiving money from SAS to sell you something. But to my knowledge, to do what you want to do, you want a highly powerful package to understand natural language processing, and SAS text miler, which is available in a SAS enterprise miler, may do what you want to do. Okay, so I hope I can answer your questions. Okay. Look like no more questions, right?
Right.
Yeah.
Okay. Thank you, Dr. Cho, and thank you everyone to participate in our online webinar. And I'm hoping next weekend we can have you here as well to explore more about the data science or artificial intelligence. Okay, the time is done, and thank you again, Dr. Cho. Thank you for your time, and looking forward to work with you in the future.
Okay, see you in the future. Okay, bye.
Okay, bye.